All right, so let's start here. In the diagram below, right triangle ABC, altitude CD. So if CD is an altitude, I know it forms right angles. And the altitude is drawn to hypotenuse AB. So in right triangle ABC, C must be my right angle. All right. I got three triangles in this diagram. The big one I'm going to call triangle 3, and the little ones I'm going to call triangle 1 and 2. Can you guys please compare, take a look at triangle 1 and triangle 3, the big one? They both have a what type of angle in them? A right angle. And I believe they also share an angle, which is what? Angle 1, triangle 1 and triangle 3 both share what angle? Angle A. They both have right angles and they share angle A. What symbol am I going to put in between here now about 1 and 3? Similar. Angle, angle. Two and 3. They both have right angles and they both share what angle? Angle B. What do I know about 1 and 2? Or what do I know about 2 and 3? Similar. 1 and 2 are both similar to 3, so what do I know I need to know about 1 and 2 now? Forget about angle, angle. They're both similar to 3, so 1 and 2 are also similar. All right? This is what this problem involves. I need to match up sides. Okay? I need to match up sides here. And this is why this is a cruel problem. It's tough to match up the sides. You know, the first time, I'll be honest, first time I looked at this problem, I saw altitude to the hypotenuse. I thought this might have been a Hill-Sass question. And I went through each multiple choice and did AD's an H, AC's an S, CD is an A. Oh, that doesn't fit into Hill-Sass. And I went through all 4 of them and nothing fit into Hill-Sass. Okay, nothing. So that's why I need to go through carefully now and figure out which one of these 4 actually matches up to the sides. So let me give you a little technique. All right, little technique here. This is the big one's a right triangle, right? So what I'm going to do right now, Caitlin, this is your problem right now. A nice, give me like go by tens here. Give me a nice angle measure for A. We'll make up 30. Fine. That's 30. Well, guys, what do you know about similar triangles? Corresponding angles are congruent, right? So B's got to be 60. Everyone agrees? 30, 60, 90. What's got to be this angle here? This angle is going to be 60. And one next to it, 30. I think it was the second day of review last week. I showed you guys how to use the angles to match up the sides. All right. So for instance, I'm not even looking at the multiple choices yet. All right. Let's go triangle 1 to triangle 2 right now. Let's compare those two similar triangles. What's the side across from 30 in triangle 1? What's the side across from 30 in triangle 1? CD. What's CD going to match up with in triangle 2? The side across from the other 30, which is? All right, Caitlin, going back to you. Give me another side in triangle 1. I already took CD out. AC. Okay, AC. That's across from the 90. What's across from the 90 in this triangle? Across from the 90 in triangle 2? So across from the 90 in triangle 2, B, C. So this is a correct proportion. Okay, I'm just going across from the congruent angles, the sides across from the congruent angles in each triangle. So what I got to do here carefully is go through each one of these right now and try to figure out which one's correct based on being across from the congruent angle in the correct triangles. Did I get the one here or no? AC, CD, and BC. BC. No, I don't think I hit it, did I? Because I was just picking a random one. I thought I was going to get lucky here. CD and BC, nope.
I understand it though, so it's fine.
You sure?
Yeah.
Okay. All good? If you're struggling, like here, I would have struggled just like you guys trying to figure out what sides matched up, put angle measurements in, right? That you know are congruent because corresponding angles match up, and then say, okay, across from this 30 matches up with the side across from that 30. Lauren?
Number 6.
Is this the... Oh, we're good here. Yep, good call. I don't think I talked about this in this class. I think period 2 I did, but not here. Classic Regents. What's the center and radius? All right, first thing we need to remember is the equation of a circle. So let's get that jotted down. Equation of a circle. I'm going to make you guys work. If you don't know it, if your number comes up, where can you find it? There you go, cold hard fact sheet. I'll start you off. X minus h squared, but somebody's getting the rest of it for me. Equation of a circle. 9, equation of a circle. X minus h squared. Y minus k squared, all equal to what? R squared, yep. H and k, those numbers you plug in, that's the center of the circle. R by itself is the radius length. Unfortunately, the one I gave you in the problem does not look anything like our equation of a circle, doesn't it? It does not. So I need to convert it using what process? Just yell it out if anybody remembers what process to convert it into circle center radius form here. Completing the square. Okay, I need to complete the square here to make it into our equation of the circle. So let's complete the square. I'll do it over here. First thing, number on one side, x's and y's grouped together on the other side. So somebody's going to do that for me right now. The number I'm talking about is 39. That has to be on one side, all the x's and y's on the other, but all grouped together, please. All grouped together. So please do that for me right now. 13. Can you group the x's and the y's together and get the 39 on the other side? I'm ready.
8 or...
I already have the x squared here, so yeah. Get the other x with it. How?
Divide it.
Where's the other x up here, Megan?
On the other side.
Where? What is it? What is it? Name it.
8x.
8x. How do I move it over? It's positive right now. How do I move it over?
Subtract it out.
Minus 8x. The y squared's over there. What's got to go with it?
Plus the 6y.
Plus 6y equal to 39. Everyone's with me so far. Next up, you need a c value twice. Ready? X squared minus 8x plus something plus y squared plus 6y plus something equals 39. Anybody remember how to find that something? Paul?
Divide by 2 and then square.
Half your b values and square them. So everyone take half a negative 8 and square it for me in your mind right now. 10. Take half the b value, square it. What's my new c value? 16. Do it again for the y's. Half of 6, square it. 9. Don't forget this. It's unbalanced. What do I mean by unbalanced right now? Talk to me. 2. Why do I say it's unbalanced?
Because there's 16 and 9 on the left side.
So you better add it to the other side. Good, Matt. So I think I get 64 over here. Factor now. Factor. Now we're going to make it look like the circle equation. Multiply to 16, add to negative 8. Multiply to 16, add to negative 8. Where are you going with this one? 18? Multiply to 16, add to negative 8. Got to be the same numbers too.
-4.
-4, -4. Done. Multiply to 9, add to 6. Multiply to 9, add to 6. 12. 3 and 3. So x plus 3 squared. There you go. Completing the square to make an equation of a circle. All right, what's the center now? And what's the radius? x minus h plus y minus k. What would I plug in to get those numbers there for a center? Oh, 7.
Okay, your center is gonna be 4, -3.
And how about a radius if 64 is staring you in the face?
8.
There we go. I don't know what I'd put more money on, partitions or completing the square to be on there. I don't know what I'd put more money on, partitions or completing the square. I'd probably put a couple more dollars on partition, I think, but I'd put a ton on here too. Lauren, yes? Others? Eva?
Wait, so why is it 4 -3 instead of
Okay, remember the equation now. X minus h squared. So what number did I just plug in for h? Just 4. Because if you plugged in -4, now I got minus a -4, which becomes +4. So that h value had to have been 4. Over here, y minus k squared. How did I get a +3? By plugging in another negative number.
Okay.
Right?
Yeah.
Good. Others? Shayna, you're on deck, Mahmood.
22.
I said you're on deck.
Oh, wait.
Shayna, you're up.
I don't know what that means.
7? Who haven't done this one yet? Parallelogram properties coming up. You guys ask a lot of questions. I love it. Not saying that bad at all. Love it. All right, what do I got here? Angle B is 75. How do I get to measure EFA? This bad boy right here. Oh, yikes. Okay. Make sure we read the directions. I got a parallelogram. I got CF bisects DCB. And I have DG bisects ADC. Woo! Wow. A lot going on there. We ready? I don't know. There's so many ways to get to this. What's the best way for me to get there? How about you name an angle? There you go. You guys, tell me an angle you know. All right, just tell me an angle you know and why. And I'll just follow your lead instead of trying to tell you where to go. That's not great teaching. 8. Wherever. Lead me somewhere here, Charlotte. I got 75 as angle B, and it's a parallelogram.
So angle D is 75?
Okay, angle D is 75. I'll take that. Opposite angles congruent. Somebody else keep building on what she says or go somewhere else. I don't care. Let's go. 5. Where else can I go?
So that's nice. Right, so CDP would be like 75.
Okay. Like, what is it?
37.5.
Thanks, Greg. Next up. We'll get there eventually, right? We'll get there eventually. 6.
Angle C is, well, I have angle DC equals 52.
Okay, this angle here, 105, and you're cutting it in half, right? 52 and a half. This is fine. We'll get there eventually. We'll get there eventually. It's a parallelogram too, remember? Parallelogram. Where else can you go now? On wherever you want to go. Take us. Making you think. 5, Greg, back to you.
So A would also be 105.
Okay, A would be 105 as well. We're getting there, right? I'm running out of corners, and so is everybody else now. Where else next? 9. Oh, coming back to you, Shane. Here we go. You got it. Would be what? Is it? I don't know. Is it? Does that up to? Yeah, I think it looks like 90. 180 degrees, right? All right, let's keep trucking. I'm making this as painful as possible. Matt, what else?
Angle F and G is 90.
This guy. This guy. That's 90. Good call. I asked for it. You gave it to me. 12. This might be the toughest one now.
Angle DEF is 90.
It's an angle.
Don't. Who's 15? Don't even do it. Don't even do it.
Angle CEG is 90.
Meg, 1. You're out of luck now.
Uh,
We got to find a legit angle now.
Angle EFG is 52.5.
52. Good job. I've been waiting for somebody to do this. It's a parallelogram, right? Opposite sides are parallel. What type of angles did you just give me there, Meg? With 52.5 and 52.5 up here. Alternate interior. All right. Can somebody please finish the problem now? Jesus. Can you please finish the problem? Please. 10. How do I find my missing angle?
It's
180 minus 52 and a half. What do we got there? Anybody? 127 and a half. Good thing this wasn't a proof, huh? But did we get there, Shannon? We got there. I know you're up next. I know that. I didn't forget.
Wrong answer.
What?
You circled the measure of the EFA, right? Isn't that what you're doing?
EFA is
Is it not like this? This one?
What do we got to go back to day 3? How to name an angle?
There's no way it's less than that. Okay, I got you.
You follow the order of the, like, do I have to, remember I used to do that back in the day with you guys? Guys, take your pen and pencil, go to E to F to E, trace it out. Where's my angle?
Isn't this one opposite too? Alright, whatever. Yeah, alright, whatever. I don't have time.
You sure you're good?
Yeah.
Can't wait for your question now.
22.
What was the issue with 22?
Yeah, that's fast. Should have like 2 4. So I don't get it.
I'm just gonna leave this. I won't cut it out. Got your cold hard fact sheet on you?
Alright, yeah. Take it out.
Good idea. I'm not downplaying this problem. It's a circle fact. That's all it is. When 2 chords intersect in a circle, if 2 chords intersect, what must be true? Okay. I think you'll find it.
Oh. Okay.
Good?
Yeah.
That's all it was. Testing your circle fact knowledge. I wish I had more for you. Anybody else? We're all good? Okay, here we go. I got a couple part 2s, a 3, and a couple 3s here for you. And if we have any time left, I'll leave it up to you guys. Let's see. I want to go back to yesterday. We did the area problem, right? Okay, let's go to 30. You better leave that open, Mahmood.
No. You can remember that.
Speaking of circle facts, here we go. What's angle P if measure of LZ is 56? LZ is 56. What's the measure of angle P? All right, I got one question for you. Is this angle P inside or outside the circle? Outside, or discussion's over. There's only one way to find an angle on the outside. Okay, if you need to refresh your memory, get your facts out. Get your facts out. How do I find an angle on the outside of the circle? I don't care how it's formed. 2 secants, 2 tangents. In this case, tangent and a secant. Every time an angle's on the outside of the circle, it is found the same exact way. Explain it to me. How is it found if it's on the outside? Look at all those circle facts in your sheets. 8, Charlotte. Yep, take your time. Everyone else keep looking. Don't tell me it's not in there.
Oh, it's on the big angle minus the one on the right way by my head.
Subtract your arcs. Angles, arcs. Subtract your arcs, correct. So, come on. Show me you're worth it, Charlotte. What 2 arcs am I going to subtract then on this diagram? Which this was not. EZ minus LZ, and you said what? Do what at the end too? There you go. Divided by 2. I think we put times 1/2, but you can divide it by 2. That's fine. All right. Thanks, Charlotte. Somebody fill in the values now of those arcs, EZ and LZ. 9. Say that again, Shannon. Yep. How'd you get 124 for your classmates that are wondering because they don't see 124 up there? Yeah, this is a semicircle because a K is the center, so EKL must be the diameter. EZL, that arc, is 180. Great job. Angle P. 1. Meg, when you're ready, give me that value. 35? Yeah, we're okay there. 34? I'm not the one with the calculators. 34? 34.
Yes.
Okay. Look, easy 2 points if you know the rule. All right, easy 2 points if you know the rule. All right, let's go to a part 3 one here. Oh, look who's back. Congruent triangles, 33. It's been a while. Actually, just the other day. Oh, this one's great. Gonna have you guys in fits. There's not much to it. I love it. All I'm gonna give you is 2 triangles are congruent. Prove me another pair are congruent. Woo. Now, look, also remind yourself, what part is this in? Is this a part 2 or a part 3 question? Part 3. So it's probably going to be more than, 2-3 steps. All right, probably more than 2-3 steps. We're going to have to put some work into it. So I know 2 triangles are congruent. Triangle ABE, congruent to triangle CBD. And now I'm just reminded of another reason why I decided to pick this one. You are, and it's not on your checklist because it's not required, but you can bring in colored pencils, highlighters to highlight your diagrams. Do not do your statements, reasons in them. Okay? Unless you would like your writing hand detached from your wrist. All right? But you can bring in colored pencils and highlighters to the exam. You guys ready to roll on this? Here are my 2 triangles. I'm not going to highlight it because it's going to be a hot mess if I try to highlight everything. There are your 2 triangles right there. Without knowing anything, give me something that's true. Without knowing that these 2 triangles are congruent, you don't need it. Give me something that's true on those 2. Without even knowing the other pair are congruent. Don't need them. To say what? 11. I got vertical angles congruent. Great job. Angle AFD is congruent to angle CFE. Vertical angles are congruent. If you want to keep track, because these proofs might get a little long, we got ourselves an angle, don't we? We got ourselves an angle. All right, good job, Paul. Let me highlight the triangles that are congruent. ABE with triangle CBD. Are there any angles or sides that also share angles and sides with the ones we're trying to prove congruent? Are there any angles and sides in the two congruent triangles that also are shared full ones, not partial, full ones? Let's go. Lauren, everyone agree? Take a look. Lauren says, hey, A and C are in both pair, and they're congruent. I just need somebody to tell me why A and C would be congruent. How do we know they're congruent? Remember, the triangles were congruent, so why are A and C congruent then? C, P, C, T, C. One more, right? We just need one more pair. Darn it, be strategic about this last pair. Do you think we're going to find another pair of angles? No, because if you're trying to prove them congruent, angle, 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 even though some of you love it to write it down on your papers, still not a way on June 1st to prove triangles congruent. Don't waste your time finding angles. Look for sides now. Look for possible sides that could be congruent. Stop wasting time on angles. We're done. We're done. We know the third pair's got to be a pair of sides. So start looking at these triangles and say, how can I find a pair of sides? Don't start making up stuff because you're desperate. Definition of bisects, midpoint. You know those words aren't there, and you're better than that. All right? Don't start wasting your time. Don't make up words because you're desperate. It's there somewhere. Find it. It's there somewhere. Why two pairs of sides are congruent. And there's only one given. The triangles are congruent, so you better go back to that part. If those two triangles are congruent, what sides are equal? Do those sides lead me to sides in the smaller triangles? Anybody starting to see anything here? Anybody see a pair of congruent sides in the big ones that may lead to something in the small ones? Stop looking at angles. We're done with the angles. Start looking at the sides that might lead to another pair of sides. Paul, you see something? DBN. All right, that is one pair that's going to help us out. DB congruent to BE. How's that going to help me get sides in the small one? Maybe Paul knows. Or maybe you just threw that out there to... Stop! You're done. I want your classmates to keep going with what you said. A question.
So, that's when you find those, it's CPC to C, right? So could we, you know how like you said
Combine them in the step 3? Yes, that's fine.
Okay.
I just wanted to separate it so everyone saw what I'm doing here. Jonathan, you got something for me?
We know BC and AB are congruent.
Hey, does everyone agree with Jonathan's statement? BC in my green one, congruent to BA in my red one. Darn right. BC and what was the other one? AB. CPCTC, and yes, like Lauren just asked, you could all combine all these in the step 3. Where am I going here? Where am I going? Look at these sides. What can I do with them to get a side in the smaller triangles? Caitlin, let's finish this off. I can subtract them. Boom! There you go. Good find, Jonathan. Good find there. What's your predicted score?
At least over a 90. 100 though, so we can call Mahmoud's house and tell him to get 100.
First off, I'm gonna get it.
Okay, first off, let's stop right there. We've talked about this already. The only way you're going to see 100 is if you do this test with Quan, and maybe your combined scores will be 100. Okay? Too harsh? Too harsh? So people just picking it up.
No.
Oh, is that what it's going to be? 100 and 0?
Combined.
He's not going to get
See
anything?
what happens.
AB minus BC minus BE. What's the 100 challenge reward, Jonathan? A jacket? Pants.
Maybe you could give me one of Elon Musk's flamethrowers.
No,
Yeah, no.
I'm good, thanks. I like my job. I'd prefer to keep it. Thanks. And then right after subtraction, we always go substitution to say the sides what is that? AD and EC are equal. And then now there's your pair of sides. Now we could say the triangles are congruent. I just need a method from one of you. Because it could be angle, side, angle, or angle, angle, side, depending on where you think that side is. In between or not. Angle, side, angle, or angle, angle, side. What do you got for me? 15? Yep, that side is not in between. Whew, that was a part 3 proof. How we feeling, all right? Okay, I still have one more to do with you here, and I really want to do it and not leave you to your own. So 35. I want to make sure we are good on what is expected on a coordinate geometry proof. Okay. Number 1, organization. I can't have step number 1 here, step number 2 here, step 3 up here. We need a roadmap to follow your proof. Okay, organize it. Number 2, am I allowed to correct your test? No. Why do I say that? Write as neat as possible, please. Write as neat as possible. I can't help anybody out trying to read your writing. Right, so here we go. Prove triangle ABC's isosceles. It's on the next page if you're looking for where the graph is. So go ahead and graph it. So we can prove it isosceles. Graph is on the next page. Tonight, suggested problems. I'm going to have you guys finish parts 2 and 3 tonight. We've done a ton of it already, so there should only be a few questions left. So tonight, finish parts 2 and 3. Tomorrow, if you want to prep, we're going June 2019 tomorrow. The next exam, June 2019. We should be lucky if this is the proof, a coordinate proof. All right, I had you guys graph it for a reason. We're going to try to prove it's isosceles. Can you just, so we save ourselves time and don't have to do the lengths of all 3 sides, can you guys kind of tell by the diagram probably which of the 2 sides are going to be equal? Which 2 sides do you think? What do you think are the 2 congruent sides that we're going to try to prove congruent? AB, what do you think? AB and BC? AB and BC? Yeah, that's what I think too. So we're going to have to find the length of AB and the length of BC. How's that getting done? How's that getting done? Meg, how am I going to find those lengths? That'll find the area. Right? That'll find the area. I need to find how long it is from B to C. How long it is from B to A. Distance formula. Or if anybody doesn't like distance, what's the other alternative we've always suggested? Pythag. Make a right triangle out of it where each side's the hypotenuse. That's your call. Distance formula. I won't have you guys waste the time to go into your formula sheet. x2 minus x1 squared plus y2 minus y1 squared. So let's subtract our x's. I lost my spot there. There, subtract my x's on AB. Negative 5 minus 1 all squared plus 3 minus 2 all squared. Square root of 37. Look good. 36 plus 1, 37. And let's hope we get the same thing for BC now when we subtract our x's and our y's. So BC is going to be negative 3 minus 3 plus the y's. Well, I did it backwards. Not that it matters, but try that again. BC, x is negative 6 minus 5 becomes plus 5. And then there, my negative 3 minus 3 squared. Also comes out to be 37. Someone's going to get jacked up here in a second. Guys, we're good. We can hear you. You're good. Sounds loud. Way to go. What did we just find? What did we just find? You show me the formula you used. Now you show me what you learned from it. What did we just learn by showing radical 37s for both? 6, what did we just learn here? AB congruent to BC because distances are equal. Yes, Tammy.
But technically, wouldn't you have to do AC just to prove that it's not equilateral?
Even if it is equilateral, triangles are isosceles.
Oh, all right.
Remember, as you go down, it's kind of like squares or parallelograms.
Yeah.
Okay, so no, doesn't matter. Okay, because even if it was equilateral, it's still isosceles. Okay, distances are equal, and then a finishing step here that says what? Triangle ABC is isosceles. And then tell me a good y here. What would be a good y for you? 16? Because? That's fine. I'm not looking for magic words here. Just get the point across. That's all I'm looking for. Because two sides are congruent, or two sides are equal. There you go. And I'm going to finish it here with the second part, and then we'll finish this proof tomorrow, first thing in class. Can you guys help me find point D that makes this into a square before we go? Where's point D that makes this into a square? A, B, C, D is a square. See, everyone thinks square, all sides equal. Think more, though. Think more. AB, side AB, and when I find D, side CD will be what to each other? I know congruent, but also what? Parallel, which means they're going to have the same slope. So quickly, up and over how many from A to B? Up 1 over 6. Look where I'm going to go now from C. Down 1 over 1, 2, 3, 4, 5, 6. I could have also done it using the slope of BC. That's the easiest way. Use your slopes. Forget distances. Oh, boy. So what's point D? Point D will be 0, negative 4. And we'll finish the square one tomorrow. I'm suggesting parts 2 and 3 today. 2 and 3. June 2019 tomorrow, after we're done with the square proof. Good job today.